Thank you so much for the invitation to speak today. And we're going to be speaking about a really exciting topic over the next 10 minutes, which is how well the HPV vaccine does truly prevent cancer. So just as a reminder of how HPV causes cervical cancer, as we know, in most cases, once HPV has snuck its way into our system, eventually our immune system will respond to it and will actually suppress and clear the virus within 1 to 2 years. It's when our body doesn't clear that effectively that, of course, it can set up the environment where usually over decades, HPV can progress by creating an environment conducive to cervical cancer. And just a reminder that overwhelmingly, as you can see in the blue colouring, on this figure, it's those most oncogenic types, 16 and 18, that are responsible for, as you can see at the top, most cervical cancers, but also all of those other HPV-related cancers that we're familiar with that you can see are overwhelmingly caused by 16, 18. And then there's another group which are now covered very well by the 9-valent vaccine that are also substantially contributing to the cervical cancer burden. So fortunately, as you all know, we now have this incredible tool, which is the prophylactic human papillomavirus vaccines, which actually work by preventing infection in the first place. And this is just a diagram that reminds us that normally the HPV virus needs to actually find its way through a breach in the epithelium down to those basal epithelial cells, where it needs to go and undergo a conformational change in order to enter that cell. And these antibodies that are produced very strongly when we're vaccinated actually prevent this from happening. So this is how these vaccines are protecting us against cancer, by not letting those nasty types in the first place. And of course, we're now targeting our efforts. Of course, all the vaccines cover those two most oncogenic types, 16 and 18, as you can see, with those virus-like particles. So just the L1 protein of the virus expressed in those round spheres, but also the 9-valent vaccine also contains the next 5 most common oncogenic types found in cervical cancer. So I always like to reflect on how far we've come since 2006, when we first licensed these vaccines. We've given roughly 500 million doses around the world now. So we have an absolute wealth of evidence that these vaccines are very safe. They're very immunogenic, even with less than 3 doses, and we know they're very effective, certainly against HPV infection, genital warts, and those precancerous cervical lesions. In the real world, not just the trials, they create amazing herd protection. They do indeed work in males as well. They produce protection at sites other than the cervix, and they do have some cross protection against non-targeted types. But the most exciting thing that's come out of the last couple of years is evidence that they actually do prevent cancer itself. So let's briefly talk through that. So this is a truly groundbreaking and exciting study, and this, I think, is probably still some of the strongest evidence that we have. And this is a study published by Lay et al. In 2020, who used the fantastic registry infrastructure that they have in Sweden to effectively see what happened to over 1.6 million females in Sweden, followed through to 2017, with the quadrivalent vaccine having been available since 2006. And what you can see on the right there is a separation of the curves over time, the cumulative incidence of developing cervical cancer per 100,000 people. The orange line is the unvaccinated group, and then the blue line is the group vaccinated at an older age, so 17 to 30, and the green is those vaccinated at a very young age, under 17. And you can see that the incidence rate ratios for those vaccinated under 17 is it's producing 88% protection, so 0.12 with a strong confidence interval there, showing that these people who are vaccinated are less likely to develop cervical cancer, substantially less likely. And this is adjusted for known risk factors as far as possible within the registry system. So really beautiful evidence that if you were vaccinated, you're much less likely to get cervical cancer in the real world. Moving on to one of their neighbouring countries, in Denmark, they also have amazing registers which allow them to do the same thing. So identify who was vaccinated, who wasn't, and follow them forward in time. And here we've got a cohort of nearly 900,000 females, and very similar findings again showing that the younger you are when you're vaccinated, the better protection you get against cervical cancer. And this is not surprising. We know that these vaccines work by preventing that very first entry of HPV. So if you're older, you're more likely to have already encountered HPV. So the vaccine has less chance to protect you. We also have a slightly different type of study available to us, and this is a study that followed 20,000 females in Finland, again using their wonderful registry infrastructure that they have there. And this was actually combined cohorts of people who'd been in the randomised control trials of both the bivalent and quadrivalent vaccine, and also in some cluster randomised trials of whole villages of people who were and were not offered the vaccine. And they were, again, followed up for about 11 years. And they were able to show in their registers that there were 17 HPV-related cancers in the control group, but actually none in the vaccinated. And so they found vaccine efficacy of 100%. Now, I think this study design is slightly less robust because I think people who participate in randomised trials are probably slightly different to people who don't. So there's probably a bit more bias in this study. But again, it's pretty convincing if there were no HPV-related cancers in the vaccinated group, strong supportive evidence. And more recently, we've had this study that's come out of England, which is actually a modelling study, but it does use their cancer registry data and has a look at HPV vaccine coverage in the different cohorts and compares it to the cancer outcomes. And here you can see in their different cohorts over time. So moving down from the blue to the red, it's the younger vaccinated cohorts. So those who were vaccinated prior to sexual activity. You can see that they've estimated a relative reduction in cervical cancer by age at vaccine for 34% for 16 to 18-year-olds, 62% for 14 to 16-year-olds, and 87% if you were lucky enough to be vaccinated at 12 to 13. So again, very strong convincing evidence. And of course, I want to finish by sharing your evidence that you have from the US. There's actually several studies that show this, but this is a particularly nice diagram, I think. And this is what we call an ecological study. So here we're not looking at who was vaccinated and who wasn't, as in the other studies were, but just time trends. And you're lucky in the US, you have such a big population that you can actually follow trends of relatively rare cancers like these over time with enough power to show significant changes. And that's exactly what you see here. And there's cancer registry data. And you can see that in the young women, 15 to 20, a more marked decline in the vaccine era, which is what the graph shows on the right there, for those squamous cell carcinomas accelerating to 22.5% per annum decline in more recent years. And also, importantly, those adenocarcinomas that we've never been very good at preventing with traditional Pap tests, and smaller but still significant declines in the next age group up. As I mentioned, there are other US studies that have very similar findings using similar data, and there's three mentioned on this slide, and the figure there is from the Liao study from this year, which is just looking at those cervical cancers in 20 to 24-year-olds. Again, you see that marked decline, and the blue line there is showing how HPV vaccine rates were trending up at the same time. So I hope I've convinced you that we now have data that these vaccines truly prevent cervical cancer. I just wanted to finish by talking about the challenges we have in Australia. Although we vaccinated a huge number of young women in our country right from the beginning, we have a small population and we already have quite low cervical cancer rates. So we unfortunately have not been able to show that lovely ecological time trend like you have. And this is just some of our most recent data that we have. And I want you in particular to have a look at that grey line there, which is 25 to 29-year-olds. And I think I'm quite convinced that we've reversed otherwise upgoing trend, and it's definitely trending down, but you have to pick the eyes out of it to make it statistically significant. And certainly for our young women, you can see the rates are so low and they bounce around a little bit. So we're really waiting we don't have beautiful registries that automatically link like the Nordic countries, but we are undertaking we've done them before, linkage between our HPV vaccine register and our screening and cancer registers to hopefully produce data that shows that vaccinated and unvaccinated women now have different rates of cervical cancer. And with that, I will thank you for your attention, and I'm happy to take any questions after the session. Thanks so much.